Morning guys, this is lesson 3 of the probability unit. On Friday, we saw how to prove if two events were independent in terms of probability. And we're actually going to focus on the same topic today. We're just going to utilize a different formula. So quickly in the do now, why is the act of flipping a coin an example of independent probability? So if we're talking about independent probability, we're basically saying that one event does not have any influence on the other event occurring. And the proper answer to this one would be choice A, because the probability of a particular result of a coin flip is not affected by previous coin flips. So the formula that we're going to be using today looks slightly different. We're not going to see the symbol for given or the word given if it's stated in words. This is our alternate test formula. For proving if two events are independent of each other. And notice I said it's a test, right? When we utilize this test, we're really trying to figure out if these two sides are equal, right? And if they are equal, that's when we can conclude that the events are independent. If it turns out that the sides are not equal, that's when they are not independent, or you can simply say dependent events. They do have some sort of influence on each other. We see a new symbol here. This is the symbol for and. Okay, so I used some of the same examples that we did on Friday, just to show you that this formula also would produce the same results. So we have the same two-way table. And is the probability of mom being grouchy independent of it raining? So, unlike the formula from Friday, there are 3 parts to this test that we have to analyze. So we'll say the probability that mom is grouchy is our event A, right? So let's see, the probability of mom being grouchy. So out of a total of 365 days, she was grouchy 73 of them. Right? So I'm just going to replace that over here, right? Times event B, which would be the one that it is raining. So find the probability that it is raining. So out of a total of 365 days, it was raining a total of 35 of them. So that's going to be our value for the probability of event B. Okay, equals, but I'm putting a question mark over it because again, this is a test formula. It doesn't always hold true. That's what we're trying to figure out. The third part, all right, we just went over that this is the and symbol. And we have to figure out the probability that mom is grouchy and it's raining. So out of a total of 365 days, it is raining and she is grouchy. Well, that's when we're going to look for the intersection of these two, right? And she's grouchy and it's raining 7 times. So that would be 7 over 365, right? So that would be our fraction for over here. Okay. And then what we're going to do is now we're just going to go to the calculator. And we're going to do alpha y equals, let's see here. So we have 73 over 365 times 25, 365. All right, so let's see. I put in the left side of the equation and multiply those two fractions out, and I actually did get 7 over 365. So I don't even have to really compare decimals here because the calculator told me the fractional form on the left side. So that's great. So they are in fact equal, so then we can conclude that these two events are independent of each other. They had no influence on one another. Okay. All right, so this is our Model 2. Just move my camera up here for a little bit. Okay. So again, we saw the same two-way table on Friday. We're just going to utilize a different formula. So we have a survey of 57 sixth graders and the results on what their favorite subject was recorded. Does it appear, based on the data in this table, that the preference for social studies as a favorite subject has dependence on a student's gender? Show the analysis and explain your findings. So you can call them whatever letters you want, but as I mentioned on Friday, it's good in your two-way table to label. So I'm going to practice that here. So I'm going to say that social studies is my event A. You could use S for social studies. It really doesn't matter. And then I'm going to just choose female for my event B. And if you want to use F for female, that's also okay. So what I'm going to do is I'm going to record our new formula. But again, I'm really going to put that question mark over the equal sign because we don't know if this is going to be a true statement or not, right? So let's see, the probability of event A happening, which was the probability that a student likes social studies. Luckily, our totals were already given to us. So out of 57 students, 19 preferred social studies, right? Times. My event B was female, just being female out of these 57 students, and there were 30 of them. Excuse me. So it'll be 30 out of 57 equals, but we're really not sure if it's equals, so we're going to put a question mark there. And the probability of event A and B happening at the same time. So we're going to look for the intersection of this column and this row, and that would be 10. So there's 10 students that are female and prefer social studies out of a total of the 57, right? And our job is to figure out if this is a true or false statement. So I'm going to put in the left side and let's see. Oh, it worked out very well again. So we got 10 out of 57, which is exactly the same quantity as the right side, right? So then we can conclude that the preference for social studies as a favorite subject does not have dependence on the student's gender. These are independent events. So explain does imply that we have to have words here. So based on our findings, the probability of A times the probability of B equals the probability of A and B. Therefore, the preference for social studies and a student's gender are not dependent. Or you could simply say independent. All right, so I'm gonna make an additional video. You should practice 3 and 4 and then check with the next video to see if your results are accurate.